Guys,
This
I'm
guy's here. This looks. This looks brighter.
you can't use them.
And this one looks.
Just screencast that you need to use the images.
Because this one's from.
Oh yeah, never mind. Okay, sorry about that, but this is so this is these are the what a star's brightness is like.
It's hotter.
What factors contribute to a star's brightness? So one of them is a star's brightness is determined by its distance. So that means is if you put a flashlight just right to your face.
Blue is hottest. And blue because
So
it's 30,000 on here.
if you put a flashlight right to your face like this, it will be very bright. But if you have a flashlight like 30 feet away, it won't be as bright. So that also contributes to stars. Like if they're far away from Earth, like if a star is like 30,000 miles from Earth, then it's gonna be insanely bright. Actually, I don't probably like maybe 300 billion miles away. It's not gonna be bright at all. But if it's like not a billion, not billion, I meant million. But if it was like 200 million miles away, you'll see that better. But it also depends on the temperature also, and that also contributes to. That also means about its. That also contributes to its age because when a star is in its prime time in its lifetime, that means that the star will be very, very hot, and it will be, as you can see right here, it will be blue and white instead of red, and this is because of all the things are going right into the middle of the star, and then that's coming, and then that makes it, then it comes out of the ball onto the outside, which gives it a hot and bright appearance. And this happens when the star is like in its mid-age, usually prime. And as you can see right here, that it says like how this can be, because the lifetime of this star is about 10 to the 7th power of years, and that's insanely bright. But if you look over here, this is 10 to the 11th power, and it's smaller, but that doesn't really matter because of its age right now. So yeah. And also here's another one. A star's brightness is determined by not its temperature, it's actually size. So yeah, that's its size. So if imagine a huge star, like the biggest star that in the universe, which cannot be because the universe is infinite, but it could happen if all the stars are the same exact size except for one. Imagine it's huge. It would be if it was in its prime life, which means temperature, and also oh, okay. And also, oh, okay. And also, if it was really close by Earth, if it was really close by Earth, that oh, nothing happened. If it was really close by Earth, then that means it would be very bright, because if a flashlight is really big right into your eye, it would be very bright. But imagine this little tiny flashlight. It would only it would only be bright in like one eye, because you wouldn't see it out of the other. So that means that it depends on the size also. So yeah, that was my video about stars, brightness in the sky.